Good afternoon, everybody. My name is Silke Kirchner. I am Product Manager at Instrument Systems for the arena Automotive Interior, and it is my pleasure to talk about end-of-line testing of recent OEM display standards. And here is the agenda of my talk. First, I will speak about the technological advancement of the automotive interior. Then I will speak about the German OEM display quality regulations for liquid crystal displays. I will give an example of fast end-of-line display testing according to OEM expectations. And finally, I will give a brief outlook and future developments of OLEDs in the automotive interior sector. The technological advancement of the automotive interior follows a one-way path that leads straight from manual control elements and switches toward digital dashboards and smart infotainment systems. State-of-the-art technologies are freeform and touch LCDs and head-up displays. The automotive sector provides one of the best growth opportunities for displays in revenues. Forecast projects a global market growth for vehicle displays to $10.5 billion in 2023 from $7.8 billion in 2019. In order to guarantee aesthetics, ease of use, and safety to the customer, the German OEMs require an objective and universal display testing for maximum compliance. The quality regulations for an universal display testing are established within the German Automotive OEM Working Group as part of the German Flat Panel Display Forum. The OEM Working Group was founded in September 2008 and consists of representatives from VW, Audi, BMW and Porsche. On a regular basis, the OEM Working Group releases a document that is called Display Specification for Automotive Application. The document contains pass-fail criteria for liquid crystal displays in the automotive interior. And here you can see the first page of the document Display Specification for Automotive Application. The document consists out of 13 pages with over 100 test IDs. General requirements, optical requirements, quality standards, and many more are addressed. For each test ID, pass-fail criteria are given under certain experimental conditions. The OEM regulations on color require the calculation of the dominant wavelength and purity of a color according to CIE 1931. The reference point for calculation is D65 2-degree standard observer, with X and Y being 0.31271 and 0.32902 at 6504 Kelvin. In the display specification, the pass-fail limits for each color red, green, blue, white, and black are defined. For example, for the color red, the dominant wavelength has to be 623 nanometer plus 7 minus 5 nanometer and a purity of over 85%. To fulfill the OEM regulations for gamma, a full image of each gray level needs to be recorded and the luminance value plotted. The target gamma value is 2.2 with a tolerance of the exponent of 0.2. order to increase time efficiency in fast end-of-line testing, we suggest a two-shot gamma approach that allows the measurement of 18 levels of gray with only 2 image captures. A white luminance image is used for the correction of spatial luminance deviations across the panel. After correction of the gray values with the white luminance picture, the electro-optical transfer function lies well within the tolerance band. The OEM regulations for uniformity are based on the Uniformity measurement standard for displays that is released by the German Flat Panel Display Forum. The OEM uniformity regulations require the calculation of the luminance gradient Z in order to determine the occurrence of blackmura on a display panel. And here you can see an example for an automatized pass-fail testing sequence for the test parameters color, gamma, and uniformity that was conducted with our LumiTop for 2D spectroradiometric precision. For testing color, gamma, uniformity, and dot defects, 9 test images are required. That means with our LumiTop, the time per dot for such a test sequence can be less than 15 seconds, including SDK processing time. But what about OLEDs in the automotive interior? LG just announced their P-OLED cockpit solution for the Cadillac Escalade, which will be the first production vehicle with a curved OLED display in 2021. In general, we can see a great investment in flexible OLED technologies in Korea and China, impacting the automotive display forecasts. As a fast reaction to the OLED trend in the automotive interior, the DFF has found the OLED working group. The OLED working group tailors the pass-fail criteria of the document Display Specification for Automotive Application to OLED displays. Topics of particular interest for the OLED working group are, for example, lifetime and peak luminance for OLED displays, differential aging, or the burn-in effect. One major topic is also the ambient reflection and reflectance of OLED displays. The reflectance of an OLED display can be determined by the measurement of the bidirectional reflection distribution function. Such a BRDF measurement will reveal different components of display reflection, such as haze or specular. And here you can see application examples where a BRDF measurement was used to identify different reflection components. And here is the conclusion of my talk. The OEM specification is a very important guarantor for an objective display testing in order to ensure safety, aesthetics, and ease of use of automotive displays. I have shown an example for fast and offline testing of main OEM display quality requirements, such as color, uniformity, and gamma. The test parameters color, uniformity, gamma, and dot defects can be tackled within 15 seconds per dot with the two-shot gamma approach and our LumiTop with spectroradiometric precision. A BRDF measurement allows for an easy determination of reflection types, such as haze or specular, and can be of importance for reflectance measurements of OLED displays in the automotive world.